So we now have to consider 4 different mechanisms, all of which are competing and sometimes give us a mixture of the products. And I like to think of this like the Hungry Hungry Hippo game, right? And what happens kind of with this analogy is the one that reacts the fastest is the one that generally is the reaction that's predominant. So 2 generalizations help us determine if substitution or elimination occurs. And one is that good nucleophiles that are weak bases favor substitution over elimination. Right? And so these include things like I-, Br-, sulfur, Cn-, CH3COO-, etc. So notice there's those negative charges on these atoms, right? So for example, we have a good nucleophile here, right? It's a weak base. We come in and we get a substitution product. The next thing that's really helpful is the bulk of the base, and bulky bases favor elimination. Over substitution. So things like the tert butoxide ion, right? DBU, which we've talked about, and DBN, right, are all too sterically hindered to attack a tetravalent carbon, but they are able to remove a small proton, favoring that elimination over substitution. So here's an example, right? We have a strong non-nucleophilic base. It's going to come in, it's going to grab that proton, and we get our elimination product here. Now, there's other criteria that we rely on, including classifying the alkyl halide as primary, secondary, or tertiary. And so you need to go back and review those and remember whether secondary, tertiary, or primary favor SN1 over SN2 or E1 over E2. Now, let's review that a little bit, right? When you have a tertiary alkyl halide with a strong base, right, elimination occurs by an E2 mechanism, okay? With a weak nucleophile, you get a mixture of SN1 and E1 products. So if you have a tertiary alkyl halide here, right, and you have a strong base, you're going to get an E2. If you have a tertiary alkyl halide and you have a weak base, you are going to get a mixture of these 2 products. Now, with primary alkyl halides, right, with a strong nucleophile, substitution occurs by an SN2 mechanism. So we've got a strong nucleophile, it's primary, we're going to have an SN2 product. If you have a strong bulky base, elimination occurs via an E2 mechanism. So if we've got a really strong bulky base, we tend to end up with an E2 product there. Then with secondary alkyl halides, if you have a strong base and a nucleophile, you get a mixture of SN2 and E2 products. And then with a bulky base that's strong, you get elimination via an E2 mechanism. So there's an example there. Now, with weak nucleophilar bases, right, and a secondary alkyl halide, you are going to get a mixture of SN1 and E1 products. So sometimes the questions will have you, will ask you to predict both the substitution and elimination products there. So I love this summary table because it shows us primary, secondary, and tertiary, whether it's a strong nucleophile and a bulky base, right? and then what the primary mechanism would be. So if you have a primary alkyl halide and a strong nucleophile, it's going to be SN2. If you have a primary alkyl halide and a strong bulky base, it's E2. If you have a secondary alkyl halide with a strong base and nucleophile, it's going to be an SN2 and E2. Secondary strong bulky base, E2. Secondary weak base and nucleophile, SN1 and E1. And then of course tertiary weak base and nucleophile and strong base, SN1, E1, E2. Notice with the tertiary, right, there's no SN2 here. So you can rule that out. If you have a tertiary alkyl halide, we're not going to see that SN2 product. And so that's very helpful. Notice here we can rule out SN1 and E1, right? So no SN1 or E1, no SN2. And sometimes it's just as helpful to be able to rule out the things that you can't have as to rule in the things that you can have. So let's do an example. All right, so here's our example. It says draw the products of the following reaction. So the first step, when you have a reaction where you have to decide if it's SN1, SN2, E1, E2, right? You need to classify the halide as primary, secondary, or tertiary. Okay, now when you do this, right, so we come up here and we identify our alkyl halide, that's got the halogen on it, and then we have our nucleophile here. So we look at this molecule and we say, all right, we've got that carbon there, and there's 1, 2, 3 groups on it, so that means it is a tertiary alkyl halide. And according to our tertiary alkyl halide, right, we are not going to have an SN2, okay? Then we need to go and we need to figure out what type of nucleophile. So the second thing we look at is it a strong or weak base or nucleophile? And so when I go and I look at this, I see that it's H2O, and that is a weak base or nucleophile. And so these two pieces of information point me in the direction that both SN1 and E1 are possible. So if I were asked to show the mechanism, I would show SN1 and E1 mechanisms. In this case, this is just asking me for the product. So when I predict the product, I say, okay, hey, look, I know that this group is going to take the place of the bromine in a substitution reaction. And so when we think about this, we also know that if water is added, it ends up being deprotonated, and so you get an alcohol. So there is your SN1 product. Then we think about an E1 reaction, right? And we know that this is our alpha carbon, and so we have to decide what beta carbon we have that has a proton. So this beta carbon doesn't have a proton. We have a proton here and we have a proton there, right? And when we look at that, there is symmetry, and so what we find is that the double bond will be substituted the same whether we remove this one or this one, and so there's really no difference there. And so this would be our E1 product. Now, let's do another example. So we look at this reaction, and the first thing we do is we say, look, this is my alkyl halide. It's what has the halogen. This is my nucleophile. We've got that negative charge there, and that's really strong because it's got a negative charge. So we come here and we say, look, that reagent It's a base. It is a strong nucleophile and a strong base. And then we also look at this structure here and we say, okay, hey, look, there's one hydrogen on this, so there's 2 R groups. That means this is a secondary alkyl halide. When we think about what a secondary alkyl halide can do, if it's a strong base and a nucleophile, right, a strong base or strong nucleophile, and it's secondary, that's going to point us into SN2 and E2, right, as the 2 mechanisms that can occur. And so when we draw our products for the substitution, again, this does not ask us to draw the mechanism, but if we were to draw the mechanism, it'd be SN2. And we are going to exchange this group for this group. So there's our SN2. And then for our E2, we identify this as the alpha. There's a beta here. There's a beta here. We see no difference in the substitution of the double bond, whether we remove the hydrogen from here or here. And so this would be our E2 product. If you have any questions, please feel free to stop by my office. We'll work on this more in class.